Okay. Are we looking at my cover screen? If you verify you can hear me and all is good. Okay, all set. Is it recording, Jackie? Okay, cool. Hello, I'm Kyle. I'm on the Secure and Defend team, and today we are talking about some security workflow iterations that we're making. And I'm really just focusing on a couple of core workflows that we work on in Secure. Okay, first for some context though, I want to talk about what is the traditional application security workflow? Well, it starts in production once code is already in a live environment, and the development team will send a source code to a security tester. A security tester compiles and scans code. So whether the security tester is internal or external, they'll send back a PDF or maybe an Excel sheet with the findings. The development team will have to review through this, dig through false positives, and then they'll all decide what to take action against. Now, the problem with this traditional workflow, which is familiar to a lot of teams, is security is really an afterthought. So there's vulnerabilities in production, and the only way to know about it is going through this and it being in some PDF or Excel spreadsheet somewhere, and it's reviewed in production. It's outside of the developer workflow, so security is not integrated into this. And it's very cumbersome, I mean, with PDF and all of these things externally, and it's terribly time consuming to say the least. Okay, so where is GitLab's value already today? Well, it's commonly referred to as DevSecOps. And what we're looking at is really the core workflow that makes up the secure features. Now, first I'll mention that the prerequisite to all this is proper configuration of 5 scanners, and that's growing, such as more recently updating with secrets detection. But SAS, which is static analysis, DAS is dynamic analysis for in production environments, dependency scans against your dependencies in your project files, licenses are related open source licenses, so more related to compliance, and then container scanning related to, say, Docker image. Once the configuration is properly made, then they have the access to these great features. And what happens with this is the developer commits code, the scanner is then in the CI pipeline, and then the results are shown in the merge request. So the developer is aware of vulnerabilities they may be introducing and they can remediate it. And then from there, it's merged into production and it can be seen on the security dashboard, dependency lists, and license lists. Just to name a few areas, from that point on, the remediation process can take place. So this is really the core workflow here. It also highlights the importance of configuration. So I want to point out that Becca's been really continuing some iterations there on SAS configuration directly in the UI. So we want to improve that. And while this is our core workflow where it's configured and then it commits code and then pipeline runs and so on, there's also Chameleon's looking at on-demand scans. So it's a little bit outside of this workflow where it's more when you want to sort of click the button and then do an on-demand scan outside of this workflow. So that's a bit of context around this. Let's look at a scenario though when, let's say that a team creates a new project and then configures a scan type. And so what we're looking at is how that scenario relates to the Git workflow. So we see the default branch here and subsequent feature branches have the security checks applied henceforth from that day on. But that's a brand new project created. How about a project, let's say that we have customers who upgrade newly to Ultimate, or they already have an existing project. What happens then after configuration? So in this view, looking at the default branch as sort of a timeline, let's imagine that configuration, this is an existing project, configuration takes place here in this timeline, and henceforth the feature branch and the default branch have security checks in them. So that'll go back to the workflow where it displays the security findings in the merge request, and then also in the vulnerability list and other places that I showed you. But how about those feature branches that were done prior to configuration? We see here that it would be merged, and it could be targeting the default branch, and it could be merged it could be merging vulnerabilities without any scan. So there would be no detection of it, and it would be introducing vulnerabilities to production, and it would not show up on any of the in production remediation areas like the security dashboard and so on. So this is, you know, a sort of UX bug, and it's not fulfilling the promise that we made to the customer of making sure scans are there post-configuration. So we're remediating this indirectly is we're not putting the burden on the customer or developer. We're gonna notify the developer when this case is happening, when they're targeting a branch that has scans, but their source branch does not. And we're leveraging the rebase, which will help with this situation. And the way that this will help is a rebase basically rewrites history and takes that feature branch and will bring it to the head of the default branch. And so from there, since it's on the default branch, it'll therefore run a security check. So, you know, part of this workflow, the importance here is making sure we bridge the gap of these loopholes and fulfill the customer expectations, because again, you know, not having a scan when expecting a scan is worse than a vulnerability finding. Because if you find a vulnerability, at least there's an audit trail, at least you can remediate it, at least it's on the security dashboard. So this is one of the efforts and iterations to close that gap. Okay, so the next workflow I want to zoom in on, having looked at the context of traditional workflow, our DevSecOps workflow that's built into the developer environment, is then going to the next step is once it's in production, what does the remediation process look like? One of the things we're focused on is we really want to automate that process as much as possible. So this is related to our feature called the auto remediation feature, also called suggested solutions. And the reason why we call it suggested solutions is that's more appropriately where we're at now, because we are able to suggest solutions. We don't have a fully automated remediation process. So that's why just a separation of terms there. Okay, so this was a familiar workflow that we took a look at. Now, kind of zooming in here to once it's merged to production, the workflow from there is in our application, developers and security teams can review these vulnerabilities that are found in production. They can go through them, dismiss false positives where there may be some, and then also investigate positives, and then create a merge request with fixes with the development team, and then merge to production. So this is a high level sort of workflow of what that would look like. Now, as I said, there are cases where we have suggested solutions that are fixes to known vulnerabilities. Well, what could these be? There could be known patches to dependencies that are well-known vulnerabilities with patches. We have those and we suggest them today, but it could also be version updates for a Docker container. Maybe you need to do the latest update, or the version you have has been detected as a vulnerability. We know what the fixes are in some cases, and what we want to do, we did a discovery around this, is we want, in those cases where we know where there's a patch available or a version update that we know of, we not only want to suggest it, but we want to create a merge request with that fix. And so what that does is that just removes this whole process. So in this workflow, we see with this new suggested solution auto creation of a merge request, we see it's merged to production, and then a merge request with the fixes created by the system, and the developers then just review the merge request, and then they can merge it to production. Now, we did some testing around this workflow, and we had very positive results. One of the results that was not positive, you'll see here, is that the merge request is created by the system indeed. However, it would be authored by the user who configured this feature. This was really a temporary solution we wanted to propose for expediency to get the MVC out and then to do some fast follow-ups on it. But we didn't really have a ghost user, an alternative user to use. So, and the other side of this that was rather unfortunate is that container scanning and dependency scanning are the prerequisites for any of these features to work, right? But on top of that, the user would have to come and then opt into the autofix feature. So that was another downside to this. And when they came to opt into it, the user who opt into it would be the author of the automatically created merge requests. Okay, so we got some feedback that users were not comfortable with that. We also had some time in between development, which we're currently, it's in a feature flag now for release for 13.4, 13.5, I believe. And we were able to do a discovery around finding an alternative user. Now, the results of that was, let me introduce you to the GitLab security bot. Now, the way that this is going to work, and we partnered with the security team to make sure that we were mitigating any security concerns here. And it was a really great cross-functional effort to get this together. But ultimately, after exploring a number of different options, what we landed on is it'll be an out-of-the-box user at the instance level. So whether it's public projects or ultimate customers, this out-of-the-box user will be here. And one of the things we really wanted to make sure of is being abundantly clear that this is a system bot. This is some feedback we got that there's a lot of confusion sometimes about bots, whether it's their bot, whether it's our bot, or so on. And so we're being abundantly clear with that. You see in the instance level, there are no options for this bot. It is standard to the instance. And then the other thing that this really helped with is that it was opt-in by default. So no further configuration required once either or container or dependency scanning are configured. This works immediately. So it's actually, they would have to opt out of it if they wanted to not use it. And that's aligned with our convention over configuration goal for how we design. This is just looking at a merge request with the GitLab security bot. Again, making sure we're reinforcing to the user that it was created by this bot. And another major helpful item that this is a user is that it gives us, and it's sort of frugal because it's using our existing working patterns of having a user profile. But by having this pattern, it gives us an audit log of what's the activity the bot's been doing. Another great thing on the engineering side is that the only activity that this bot can do is create a merge request. It can't merge a merge request. It can't do other activities. So if it ever did get hacked, that's the only activity it's restricted to doing. So that worked with some of our security team's concerns as well that we worked through. A next step here is actually to show what projects are related to the bot. So to help further the audit log of if the users want to know at the instance level, what projects is this configured for? That'll be a next follow-up step. But for this one, we focus on the exact activity. And then the discoverability of the bot, it's just in the same workflow as searching for an author. So we see here with the GitLab security bot. In this discovery, there was a number of follow-up issues, but one that I want to really call out and give a big thanks to Jeremy Elder is the visual alignment of the existing bots in GitLab. So again, going back to making sure we're reinforcing that this is a bot and from GitLab and not at the instance level or any other bot that anyone created. So today we have the support and alert bot, and soon we'll have the security bot, but Jeremy did the avatars for this, and I think that they are really amazing. So big shout out to Jeremy there, thank you. Okay, so where does this get us at with our new workflow? So once it's merged to production, the GitLab security bot will create the merge request automatically when solutions are available for either container or dependency scanning. The developer can review the finding or the merge request here and then merge it to production. The next couple steps that we're going to be looking at and doing discoveries around, oops, a little too quickly, is shifting left more. It's a common DevSecOps term, and what that means is just bringing it more to the bringing security more to the development side. And we're already exploring options to commit fixes right there in the merge request. Our first step may just be surfacing that the patches available for download so that the developer could at least commit it locally. But this is the next step, is focusing on the merge request experience and removing these vulnerabilities or updating these out-of-date dependencies before it even gets to production. The next step also is, if it is in production, the GitLab bot creates the merge request and then merges the fixes as well. So that's what the team's working on now. Okay, as always, thank you so much. I greatly appreciate your time.
Thanks, Kyle. I'm going to stop the video.